Hi. So in this lecture, I have more examples for you. Uh, and the reason why I'm giving you more examples is because it's so important. And instrumental variable is maybe, I believe that, like, say, at least half of you are going to use some kind of instrumental variables method in your dissertation, at least that in one chapter of them. So more than half of you are going to use this, and more than half of economists out there are using some kind of these methods. So half is very conservative estimate. So anyhow, it's really important. So that's why I'm telling you more examples, and I want you to think this problem theoretically and practically at the same time. So I'll give you more examples with more thing to think about. So first example is about education. I think I have explained enough. So this is good. I will just keep this. And second example I would like to think about it is, so what is the effect of agricultural technology or say fertilizer? Suppose that you say go to a less developed country, and then the farmers in the less developed countries do not use fertilizers, even though they are in poverty and they are in hunger. They need more food. They're in food crisis, but still they don't use fertilizer. I don't know why. So economists try to study the problem why they are not using this, and suppose that the outcome is clear. Outcome is the agricultural yields. So how much you can harvest from a certain area, like an acre, and say X is a fertilizer amount. How much you use the fertilizer? So when you use 1 more kilogram of fertilizer, how much yields will increase? In this case, an omitted variable here is the farmer's unobserved productivity or unobserved, say, hardworking diligence. So the farmers who are more ambitious, who are more hardworking, are more likely to use fertilizers, right? And more highly educated farmers tend to use more fertilizers and adopt new technologies, new equipments. So because of this unobserved error term characteristics, the fertilizer use is correlated with this error term, right? So then what can we do? Like I have used this example in my job market paper, and instruments I used was the cost of. So we want something like the cost of buying fertilizers, right? So the price, like if we could observe the price or the actual cost of buying fertilizer, and if that differs across farmers, that would be the best instrument. So the price has nothing to do with the farmer's ability or the yields directly. Price doesn't have any direct effect on harvest. So what I used at that time was distance to market or road. It's less developed countries, maybe the poorest country in the world. So it like you need to walk like 1 kilometer or 2 kilometers, like about a mile, more than a mile, to go to a paved road. So bring fertilizer from the market is quite difficult. Also, I considered rainfall, because rainfall in the previous year, because higher rainfall, more rainfall means more harvest, better harvest. So if you had a better harvest from the previous year, then you can afford more fertilizers in the following year. That's why I use this, and so the rainfall is relevant, and obviously the rainfall is random, right? It's totally random. You cannot correlate the rainfall. How much it rained last year? is not correlated with anything like your ability or your harvest next year. So exclusion assumption is also satisfied by this instrument, right? And let's think about the third example here. It is, I would like to see the number of children on mother's labor supply, like working hours, or you can think about employment rate. Anyhow, so if a woman has an additional kid, then how likely she works, how much she works less, or how likely is she to quit her job. But the problem here is number of children is also correlated with the mother's unobserved characteristics, like how professional, like how much she wants to pursue a professional career, or how ambitious, or on the other hand, how much the mother wants to have larger family, or how much the mother spends time with their children. So those kind of unobserved characteristics, the mother's tendency, has direct effect on the decision of having another kid. So because of that correlation, the number of children is endogenous correlated with the error term, right? So then we need an instrument. The instrument is very interesting. So it's one instrument that is used by, I think it's also Angrist and Evans in a paper by Angrist. So first instrument is twins. So having twins, first let's think about this instrument. Having twins is purely random. You cannot control that. So having twins is random, so it satisfies independence assumption, and it is relevant because having twins means you directly have another variable, another kid, even if you did not want. So you plan to have one baby, but by the mother nature, you have no choice but having two babies. So it's a perfect randomization. So it is an interesting instrument. But the problem is the number of twins, the number of observations that have twins is too small in the data. So that's another problem. But it itself, the variable itself, satisfies the assumptions very nicely. And another interesting example is here is given sibling sex composition. So Angrist and Evans. This idea is really, really interesting. So think about this. So when you have, so think about it. Some families have a strong preference for a certain sex, like I'd like to have a daughter or I'd like to have a son. So then what the authors thought was that suppose that you wanted to have a daughter or a boy, but suppose you wanted to have a daughter, but unfortunately you had two boys. Then if you had two boys, then and so by the way, if having the same sex for the first two kids is purely random, you cannot determine the baby's sex, then it is random, so it satisfies independence, and it is relevant because if you have the same sex for the first two kids, you may want to have another to have the other sex. Like if you had two boys, and if you still want a girl, then you may try once more. In the data, I don't know, but in the reality, I have not thought that way. But in the data, it looks like having same sex increases the probability of the third kid. So at least that is true. But so if you accept that explanation, then the sibling sex composition is another interesting instrument. It's a very, very, very clever instrument. So you may use two different instruments in this case. And example number 4, effect of job training on job search. So, job search. So suppose that someone lost his or her job. So during the unemployment period, the worker will get unemployment benefit, and one of the unemployment benefit is a job training program. You can participate in the job training program. I don't know what you learn there, but maybe you can get certificate, and it shows some kind of your willingness to improve yourself. So, however, we would like to study what is the effect of participating in a job training program on, say, the future wage, or how fast the unemployed person finds a new job. So it's very interesting question. But the problem here is there are two different ways of correlation. First, those who participate in the job training program can be someone who are desperate, right? So for example, suppose that if I lose a job tomorrow, I think I would not participate in that job training program because I know that I can find another job easily, right? I have a econ PhD degree. I major in like data analysis, so it's a popular job, a popular major these days. So I believe I don't need a job training program. So then, in the end, in the job training program, the participants would be those who have no skills, like low-skilled guys, or who are more desperate, who expect lower income, so they wanted to get something out of it. So that's the first potential correlation. Or the other, there is another possible channel of the correlation is those who participate in the program could be those who are more willing to work harder, more diligent, more hardworking people would participate in the program. So in that case, so if you are lazy, then you are not coming to the program. So hardworking people are a lot more likely to participate in the program. So in that sense, so there is a positive correlation between the participants' unobserved characteristics with training. So in the latter explanation, the participants have higher average error term, better traits of the characteristics. But from my former explanation, those who are desperate are likely to have lower unobserved abilities. So then it means a negative correlation. So I don't know what is dominating and what is right. But in this case, anyhow, endogeneity is quite clear. There would be some kind of endogeneity. And on IV, here is a random invitation. This is a very interesting instrument because invitation or incentives is easy to randomize. So so think about this. Suppose that there are a set of unemployed people, and you randomly choose some of them and provide, I'll say that I'll give you $100 if you attend the job training program. Then after getting the offer, the unemployed person may not attend the program. Still, the random invitation or random incentive itself is good enough instrument. So ideally, if you can force someone to attend the job training program, that is a randomized controlled experiment. That is a perfect case, but usually enforcement is not possible. You cannot bring a person from home to job training program location. So instead, you are kind of randomly advertising, giving one additional advertisement or giving incentives. Still, that is enough. because first think about this. It's random incentive, so you randomly choose who get the offer. So it automatically satisfies the independence assumption, and it is relevant if the incentive increases the probability to attend the program. So it's also obvious if the incentive is good enough, like $100. Okay, $100 is not bad. So I don't know how much it increased. Suppose that without the incentive, the participation probability is 10%. But among those who get this incentive, their participation rate is say 20%. Still, that is so. The incentive that means the incentive has some effect on the decision. The participation probability increased, so this incentive satisfies the relevance condition. Then, as you see, it is very easy way to implement a random experiment. So you don't need to force anything. You just provide incentives or just make some kind of change to their decision. So affect their decision in a random way. That's all you need. So for example, so Amazon, maybe I don't know what they are doing, but I heard that from a friend who is working at Amazon that they randomize a lot of things to see how their customers respond to that. For example, they intentionally make errors or intentionally ignore errors to see how the customers react to those errors. Or they know some transactions are fraud, but they intentionally ignore that and to see what's the behavioral pattern of those frauds. So, and there will be many more things will be used in your like in your life without your notice. And in the previous table here, the first part was natural experiments. So these examples do not have any randomization. Intentional randomization is not included here, but there are also a good number of examples where, say, participation, this example is already mentioned here, randomly assigned. So that is random assignment or randomly doing something is a good way of making up an instrument. Of course, you need to have such a data, but it's more easy. It's easier to verify these assumptions. Okay, then I think I gave you more than enough examples. So think more about those examples and see if you have understood them correctly. And I am going to go to the more theoretical setup in the next video.